Let's look at proton transfer mechanisms. And this goes for typical acid-base reactions. So, in order to have an acid-base reaction, we will have some acid. I like HCl. And we'll have to have a base. And some kind of hydroxide is good for that. And then we will make a conjugate acid plus our conjugate base. And now for the mechanism. We start to draw a double-headed arrow from an electron pair or a location of electrons. In this case, we're going to have some electron pair come from the oxygen and attack the hydrogen. And then we're drawing from an area with electrons, and that includes bonds. And we move those electrons over to the chlorine. So the net result is that we form a new bond, as emphasized here, between the oxygen and the hydrogen. And we've moved the electrons that used to be between the hydrogen and the chlorine over to exclusively be on the chlorine. So that's an example of the proton transfer mechanism. Let's do a couple more reactions just to be more familiar with this. So in this case, we have water and we have ammonia. And ammonia can act as a base, and in this case, water can act as an acid. So we will take these electrons right here and grab a proton. And then the net result of this will be the hydroxide ion with the ammonium ion. In this case, this is our acid. This is our base. This is the conjugate base. This is the conjugate acid. One more. So here's acetic acid. And ethyl amine. So this will act as our base, this will act as our acid. So you can see that all of these mechanisms are very similar. We have a base abstracting a proton, and the bond that was holding that proton onto the rest of the molecule for the acid breaks and moves over to the atom that it was originally bound to. And you can see that repeated in each one of these mechanisms. So this is a useful mechanism to know, even though it's quite simple. So thank you for joining me for this video, and we'll see you in the next one.